Our next presenter is Robert Sanderson. Robert is the Senior Director for Digital Cultural Heritage at Yale University, where he works with Yale's libraries, archives, and museums to ensure that data and other digital efforts are coherent and connected. He has previously worked at the Getty in Los Angeles, Stanford University, and Los Alamos National Laboratory. He is the principal architect for Yale's cross-collection discovery system, LUX, that I will really invite you to explore, which is built on the linked art specification for which he is the primary editor. He is also an editor for the IIIF specification. The title of his lecture today is Image Availability for AI with the International Image Interoperability Framework. Please join me in welcoming Robert Sanderson.
Great, thank you for the introduction, Terry, and thank you for the invitation to speak today. Thank you to the previous speakers for also setting me up so nicely in talking about IIIF. So today I would like to talk, of course, about IIIF, plus also linked art. Go into a huge amount of detail, but first and foremost, IIIF is a community. So there is, and the important part is it is one community. There is a global consortium with now more than 75 paid members, but you can participate in the community just as an individual or as an organization. It spans every populated continent of the world, and we have more than 2 billion images served via IIIF at this point. That community develops APIs, and that's what I'm going to talk about. If you don't know the acronym, I will explain it. It then implements those APIs in software and exposes interoperable content using that software. So I've done them in that order. There is one community, there are 6 APIs, there are many dozens of implementations, and there are billions of images and descriptions of images served. The image API, and by API we mean agreement preceding interaction. And for anyone who actually understands API, it's actually application programming interface, but essentially it is how does the client, how does the consumer of the image agree in advance with the server, with the publisher of the image, to know how to get more than just a single set of pixels. How can we do interesting things with those images? So the IIIF APIs, for example, enable deep zoom. So here is a zoom in on the Getty's irises, and it is this little bit here in the bottom, right? So it's a large number of pixels for the entire image, then presented in miniature. As Laura said, you can use it to compare content. So here, for example, are 2 images by J.M.W. Turner that can be compared side by side to look at the similarities and differences, but importantly, that can go across organizational boundaries. So 2 of these are at the Getty, and the new one, Joseph Mallard, William Turner, dates, etc., is at the Yale Center for British Art in New Haven. So this is the advantage of standards, that by everyone adopting the same agreements, we can then use those agreements across institutional boundaries without having to go and talk to ICBA, without having to talk to the Met, without having to talk to the Getty. We all just implement the same thing and everyone benefits. Annotations then are a fundamental component of IIIF, both in terms of how the model works generally speaking. An image is annotated into a space, which then allows multiple images to also be annotated into that same space. So annotations in IIIF are not just about this use case of making a comment about something, in this case a tag to say this is Europa, but also about bringing in content as well as text, including text. So if you had a manuscript page, you could then have annotations that describe the transcription, either word by word, line by line, or the entire page, as well as commentary annotations. That then allows us to provide search functionality on top of the images and the text, such as presented here. And yeah, so then here are the 4 APIs. There is the image API, presentation API, authorization, flow, and search. So you'll note then that it is not a metadata API, it is the presentation API. That is very important because we do not aim to provide structured semantic data. We aim to give the consuming application enough information to show to a human user such that they can understand the image that they're looking at. Right? So it is not for a catalog or a semantic query tool. It is for making images useful and usable by people, and thus the big question: what about AIs? Right? So we'll get to that. So the image API then is the primary way in which you get access to images, and the sorts of functionality that you can do is to ask for a region, and that's how we got down to that particular aspect of the image of the painting. So in this case, we've selected just the head from the larger image. You can then ask for that at a particular size. So in this case, we've shrunk it down by 25%. You can flip it, you can mirror it if you want to. You can then rotate it by a number of degrees, and then you can change the quality to be either full color, high definition, grayscale, or black and white. Sometimes, particularly for AI, you do want to reduce that information down to just black and white. For example, if you're trying to look for layout, then all of the colors really get in the way, and you can get a much better result by using IIIF to reduce the information given to the AI so it can focus on those aspects that it actually needs. You can then ask for it in different formats, so JPEG or PNG or WebP or TIFF or other formats. So this then is sort of the basis of how we interact with images in IIIF. The reason for this API's existence is there isn't another way using HTTP to do these sort of interactions, unlike with video and audio. So video and audio files, you can ask for a particular range, a particular area of that resource. So you can ask for 30 minutes in, and then I want another minute of time. And that's just part of the web. But there isn't that for images, because up until relatively recently, an image was such a small file that everyone was like, oh, yeah, no, we'll just ship the whole image and they'll be fine, right? But now the Rijksmuseum has a 7 terabyte image of the Night Watch. So one imagines that is not going to fit on anyone's computer, let alone in memory in a web browser. So if you want to know more about IIIF generally speaking, there are training courses for how to use IIIF run by Glenn Robson, who is the IIIF technical coordinator. There was one this week actually, so the next one is in May. But it's essentially every 3 or 4 months there is an online course. It's sort of an hour or two each day for the week with a little bit of homework. yes, if you want to know more about how to use IIIF, I'd strongly encourage you to go to one of those courses. They'll walk through everything from the APIs to setting up image servers to setting up the annotation server and so on and so forth. So when we came to design IIIF, we followed some design principles. And these design principles we have found to be incredibly important to understand because it gives us as a community a way to make hard decisions. So when someone comes to us and says, oh, we've got this great idea. We just want to do this one little thing. Can we do it? Then we go back to the design principles and say, is this a great idea according to the design principles, or is this something that falls out of scope, or does it really not fit with the way that we do things? So I won't go through all of them in detail, but the first one is critical. We scope design through shared use cases. So this is not Photoshop on the web. You can't do absolutely every single manipulation you might possibly ever want to do. We only implement those functionalities which multiple organizations both need and can implement in their systems. So they have to be shared use cases. Why does someone want it, and can it be implemented? It also needs to be designed for international use, right? It's the international image interoperability framework, not the American or the North American or the English speaking world. So everything must be multilingual as much as possible. And then I'm going to jump right down to the last one, address concerns at the right level. So if it's an API concern, then it should be addressed in the APIs. If it's an implementation concern, right, it's hard to do this in Java. It's like, well, that's an implementation problem, not an API problem. If it's a semantic question, right, how do I describe this painting, or how do I describe this photograph? That's a semantic problem, and that is outside of the scope of IIIF. Uh-oh. So when we get to AIs, who then need to understand those semantics so that they know that this is a photograph and not a painting, or this is a photograph of a sculpture, but you should pay attention to the sculpture, not the photograph, then we have a problem, and thus enter linked art. So linked art then is I would say companion, but a parallel effort with many of the same players to produce a semantic profile and API to work across cultural heritage organizations with the same sort of context as IIIF to publish and enable consuming applications. So it then can describe context and the objects in our collections and the works in our collections, following standards in a consistent, connected, linked open data way, designed in particular for usability. And we've already talked a little bit about usability from some of the questions to Laura's talk. And once you have consistency, usability, and standards, those to me are the three primary prerequisites for sustainability. Right? If you're not standards-based, it's not usable, then no one uses it, then you're not going to get the money to continue it. And if it's not consistent, then you've introduced so many exceptions, so many different rules that everyone has to follow, that you're losing that usability. So I made this slide 10 years ago for a keynote, in fact, my first ever invited keynote, but I still think it fits. So on the vertical axis, you have usability, and on the horizontal axis, you have completeness of the description. So this also goes back to what we were talking about before, right? So if you have no completeness, you don't have any description, you don't have any semantics, then you don't have any usability, right? You've got nothing to do. Then there's this steep curve, and we get to the top, and that's sort of the simple Dublin core, 15, 16 elements of there's an identifier, there's a description, there's a creator, there's a created time, and so on. But we're still not very far into that completeness, and the challenge for us as cultural heritage folks is to convince our institutions that they need to invest in going that way, right? We need to get more completeness, but not as much completeness as we get to the end, where we get to the NASA problem of, oh my Lord, we have every single piece of information and I don't even know where to start. So for linked art, our scope is how do we walk the fine line and get into that boundary in the middle of what is the most complete and usable at the same time. So not the most usable, simple Dublin core, not the most complete, side up CRM with all of the extensions and inference and belief and blah, 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 but somewhere that is as usable times complete as possible. So the data model fundamentals for linked art that is activity-centric rather than object-centric. So we focus on the production of the object rather than the object. We focus on the publication of the work rather than the work. We focus on the discovery of the fossil rather than the fossil. And of course, the collection objects are critical, right? They're the things that we look after. But everything goes through human activity, so we can then track much more easily the provenance of the objects, the provenance of the data. How did these things happen? What were the techniques? Who did it? When did they do it? Where did they do it? Why did they do it? Which then gives us a sort of core of objects being produced, created, used, and counted. Objects show or carry works. They can be about places or activities or agents or concepts and so on. So it's a relatively simple core. We can then expand out from there with additional information. Perfect. Okay, images and AI. So at Yale, we had a symposium in our cultural heritage division about what did we want to do with AI in the coming financial year for us. So we first thought, well, what are the sorts of tasks that we would want to do with AI, and what are the sorts of aspects that we care about of how the AI should function. So the tasks that we all agreed as being useful were transcription, description, summarization, classification, translation, and recognition of entities. And this, we didn't say up front, this should be image-based. We said, what do we want to do? But all of those tasks are image-based. So we then, we looked at what do we have, what information do we have? So we have images, we have texts, we have data, we have audio, and yes, you can transcribe audio, you can describe the audio. That is kind of a solved problem, as you can see, to my right, in real time with my crazy American / British / New Zealand accent. All right, I got it, good. So we then said, well, let's focus on images. What can we do with images, and what do we want out of that? So of course, the same stuff that comes in comes out the other end, both in terms of formats and quality. So you can put in images and text and data and sound. You get out images or text or data or sound. And we want the process to be reliable. Right? If we run it, it shouldn't crash. It should produce results. It should be performant, so we can't wait for a day to get the results. It should be affordable. And Yale, so far, taxes and other craziness of the American government aside, has enough money to afford these things, but it is by no means a foregone conclusion that any organization can afford this. It should be ethical, of course. It should be explainable, and it should be multilingual. Right? It can't not work in Japanese for Japanese photographs. So then, with images as input, what do we want to do? So the first thing, we want to transcribe both handwritten and printed text from images in multiple languages simultaneously, right? We don't know which page of the book is in Latin and which page is in English. If we did, then we would have already transcribed it for, say, a dual language Latin-English text. Equally, we don't know what language the comments written on the back of the photograph are in, right? So, and it could be in multiple languages at the same time, from different people at different time periods. We want to create web accessibility texts for images, which we've already seen or heard some of the issues there, or for user-selected parts of an image. So remember, if you use IIIF to zoom in to a particular region, you can't produce an accessible caption for that zoomed in region manually, because you don't know where the user wants to zoom in. So can we use AI to produce accessibility captions, alt text, for images that are dynamically generated, essentially on the fly? And good news, yes. We want to categorize images according to some vocabulary, say AAT. We want to segment images into different parts and use those segments for different purposes. Create new synthetic images. We haven't gotten to this one yet, but we're exploring. And to extract or create data either from or describing the image. So this is the cataloging use case. And we are both excited and nervous at the possibilities here for exactly the reasons that Laura was saying. So thank you for the use of one of your images. In my copy of the slides, I have it credited at the bottom, but I sent the slides too early. Anyway, so an image from the IMC to demonstrate transcription. So OCR and handwritten text recognition are pretty much solved problems at this point from my perspective. So here is an image from IMC, and it got all of the words correct in a zero shot, which just means I sent the image with no training, no fine-tuning, no nothing to Gemini Flash. So we ran another image data set of 25,000 images through Flash, and it cost us the massive $1.28. So Flash for images is very, very cheap and very, very effective. This is not something that you need to worry about putting out getting a loan to do, or worrying about it being more than a cup of coffee. So I picked this image for several reasons, but one, because there are these lines over some of the text, which a typical OCR engine will have a very big problem with, because it looks for the characters and then tries to predict what that character is. Right? It's optical character recognition, it's not a language model. Whereas a language model, it's like, oh, there must be a letter under that red line, and I know what it is from context, because it's a language model, not a character model. We also don't need to rotate it, right? That is the correct orientation for this image. It just so happens the text is at 90 degrees. And the AI reads it totally fine, because it sees where the text in the image is and can rotate it itself. So we looked for a more challenging one. So this is the verso of one of the photographs in AMC. You can see it's got handwritten text. It's all at different angles. There's both printed and handwritten. There's circles. Over here, there's crossed out stuff, and et cetera, et cetera. It got everything right. So we were actually pretty amazed that we thought there was no way a fraction of a cent worth of cost to Google is going to generate the text for this image, and it did. So, yes, HTR. Okay, medieval Latin or Arabic, etc. Okay, that's another question. Japanese and Chinese, also another question. But modern Latin characters, it does very, 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 very well at. Okay, so what about alt text? So we tried to come up with a set of images that would be as challenging as possible to the AI. I think there's about 50 images in the set, and they are all of photographic paper that have been printed and photographed not because of the photograph in the image, but because of the paper. So if you want to look at this on the web, it's paperbase.xyz. It is at the Institute for the Preservation of Cultural Heritage at Yale, and this work was done by Damon Crockett, the data scientist in that group. So we had humans annotate the images and then also read through and score each of the AI's predictions to then try to find out which models work for which sorts of images. So open models and even Flash have a very, very bad day with this particular style of image. So I'm not sure if you can see it, but there is the sculptor working on a sculpture, but because the image is rotated, all of the vision models see this as a person holding up their young son, gazing lovingly into the young son's eyes. No. If you rotate it 90 degrees, it's a totally different matter. So the open weights models have a very bad day. Even Flash doesn't do it. DeepSeek just hallucinates all over the place. With rich greens, deep blues, and warm, no, just no. I mean, I think it's probably seeing the colors in the top. Yeah. Gemini Pro 2.0, however, came up to the right answer of a classical sculpture, possibly a human figure with drapery. Right, so it saw the rotation. So it's possible, but there are challenges even in relatively straightforward content that we need to be aware of. Captioning photographs then. So here's a photograph from the Getty of a sepia tone photograph, describes a low angle view, blah, 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 right? So it does a pretty good job in the general case. It takes a second to generate the text. But, as I said before, with IIIF, you can zoom in to particular regions. So what happens if we zoom in to one region? Well, because we can then pick that region out in terms of the pixels, we can then take it, give it to the AI, and say, now please generate a description of this part of the image. It's got the context of the full image, so it knows what it is, but you say, only describe this thing that the user is currently looking at. And a second later, here is your text. The user doesn't notice any time delay because it's loading the images, it's loading the text. It all appears essentially at the same time. And of course, it focuses on what it can see within the context of the larger photograph. So this is just one example. We haven't done any longitudinal studies about accuracy on this yet, but we think that there is a strong possibility that alt text on the fly by vision language models will solve that particular problem. You've already seen this model, YOLO, or we use a YOLO-E, which, well, I'll let Christopher describe the difference in a break. But essentially, as described, you can say, find me the people in the photograph, or find the bags, find the cats, find the dogs, the hats, the cars, the whatever you want. So we gave it back that same photograph. It does a reasonable job. The only mistake that it makes for people is here. So this is the arm of the woman, but it interprets it as the arm of the man. So the reason that we're interested in this is we want to be able to then combine this with the previous two steps to say, how well did it read the transcription? Okay. So if the transcription talks about 3 people, but there's really 4, well, what does that mean? Or if the caption that was generated talks about there are 10 people in this image, but there's only 4, well, something's gone wrong. So we can go back and look at it with a human in the loop. Equally, can we pick out individuals? The question before about identity. Our experience is no. That facial recognition is great for celebrities. So if you want to find Madonna in the photograph, sure, because the AI has seen many, 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 many millions of photographs of celebrities. But for less common individuals, no, no chance. So then, users. How am I doing for time? Good. So here is my strong assertion. The world does not need yet another chatbot. We have seen chatbots put into all sorts of stupid situations with, chat with the person in this painting. It's like, no, I don't want to chat with the person in the painting because, chatbot, you don't know who the person was. You don't know what they would have thought. You don't know anything apart from what is in the catalogue that you have been fed, and everything else is purely fabricated. However, there are some advantages. So, well, why no more chatbots? They're not transparent, though, yes, improving, right? You don't know why it thinks the person in the painting might have thought that. and they give a fake sense of certainty because of their command of language, right? You believe it because it sounds confident and convincing, even if you shouldn't. And users don't necessarily want to be spoon-fed summaries of information, right? They might want, instead, to be able to interact with the information and make their own judgments if they have any sense of critical information theory. However, chatbots have done one very beneficial thing, which is to acclimatize users to ongoing interaction with the system, rather than saying, oh, my first attempt didn't work, I'm going to go back to the beginning and start again with another search, right? So at the moment, you go to a library system or a museum system or an archival search system, you type in some keywords, you look at the first page of results, and you say, oh no, that's not what I wanted, and you go back and you do another search from scratch. But why? Probably the results that you were wanting you could have gotten there more accurately by refining your previous search. And this is why we end up with facets from 20 years ago. But now, with chatbots, you can do it again and again and again, and you can get the chatbot to refine its understanding of what you want to then give you the results that you want. Right? So here is our search ecosystem at the moment. Right? So the user has some information need, the catalogers or curators or archivists understand the data, and what you want to do is get the user to talk to the librarian, right? So that would be the optimal, right? If the user could just talk to the person who knew all the information, they could discuss it, user understands what they want to know. However, what we have today is technology-mediated game of telephone, right? Where the user interacts with the screen is produced by a developer who wrote it in JavaScript, who has some understanding of what the metadata looks like, which was produced by the back-end developers that interacts with the database, that was produced by a company that has no idea what the actual objects are, but has to be used by the curators / archivists / librarians to describe the things in their care. Right? So it is no wonder that users get frustrated when they can't find the stuff that they're interested in. So we can use, however, AI to do what it does very well, which is translating language. Right? So instead of having the AI produce the answer, the AI can instead produce the query. Right? You explain to the AI, what I'm interested in is this. The AI can work with the database schema and work with the information in that schema to produce the right query to get you to the results that you want, that then is transparent and interactive, and it gives you the critical ability to be able to assess the accuracy of what the AI did for you. For example, I want photographs with a digital image of hats. This is not a mock-up, but this works in our system. And it creates you can see photographs, 105 of them with images, and in the images are hats. It did it by understanding what the user wanted and producing the graph query of, I'm looking for physical objects that are categorized as a concept that has a name of photograph. The object has a digital image and shows a work that's about a concept that has a name of hat. So it can then submit that query on behalf of the user to get to the results. Right? So now we go back to our segmentation algorithm. Oh look, there's this word hat in the query. We can then feed that into YOLO, because it's a open model, and say, find me the hat in the first 10 images, right, the first page of results. It very quickly brings back the hats. So this is a mock-up. This is soon rather than now. But you could then say, well, you searched for hats and photographs. Here is the hat in each of these photographs. At which point, we have used AI to do two things. One, to be able to translate the user's need from their understanding of what they want into the terms that the machine can understand, right, the graph query. And then to be able to reinforce the accuracy of what was the machine's response, right? So this first one, it either didn't find any hats, or the hats are so small on that image that it can't draw them. So maybe that's just a fault of the metadata, right? Maybe there really aren't hats, or maybe the hat term that is catalogued shouldn't be there, because it's not a real, it's not an important aspect of the object. To the cherry tree example, right? The cherry tree probably should have been catalogued in that image, but wasn't. So, concerns, conclusions, and then discussion. So, of course, there is the ever-present concern about reinforcing bias through using AI, and there is the ever-present concern about the total cost of doing this at scale. Right? There is the environmental cost as well as the financial cost. Right? I forget what the number of bottles of water it is, but it's pretty high. Also, that we are currently in a market share struggle cost bubble for all of these companies. They all want you to sign up with them, build your solutions using their models, and then they jack the prices, but you're locked in. Right? So everything is artificially low at the moment, which is why we are hurrying to do as much as we can to benefit from those low prices. But we shouldn't be building systems without the awareness that those prices are very likely to go up significantly in the not too distant future. It's very difficult to detect errors, even with some multi-model techniques like I talked about. And AI leads to complacency a lot of the time, right? Both in the engineers, be they data engineers or software engineers, in leadership, relying on AI to make decisions, and in users of just, oh, I just ask Alexa and it gives me the answer and I believe it. Right? So, in conclusion, IIIF then provides standardized access to images, both for humans and for AIs. And we can reduce our costs by using IIIF, by using that segmentation feature to send only the bits of the image to the AI that we need. Linked Art then complements IIIF by providing standardized access to the semantic descriptions of the collections. And together, we can use those two to feed the AI enough context that it can understand for image processing, things like transcription, description, and segmentation, and for improving the end user experience by translating from their information need into the terms that the system understands. So, yeah, I would say that AI is here. It is disruptive and it is powerful, and we need to learn when to use it, when not to use it, and most importantly, how best to use it, given the collections and facilities that we have. So, thank you very much.
Thank you, Rob, for this very clear presentation. Do we have questions? We have a few minutes, not that many minutes. Yes, please. Just wait for the mic because we are recording the session.
Hi, thanks for this great presentation. I have a question going back to your slide that says soon, ? Okay, yeah. So the image at the top, the studio portraits of two women where there isn't an identified hat. Is there a scenario, or have you talked about this with your team, I'm just curious, in which you would rescan that as a 7 terabyte image, then be able to zoom into the folks in the image, using IIIF, and then you could pull out the hats?
Yeah, 7 terabytes, no, that would be sub-molecule. It's not a very big, object. I think it would give us pause about the cataloging, because it's not using hat as a term to search within the image, doing an image-based search. It's searching within the metadata. So there is hat somewhere in the metadata. So it would also make us look at the way the system interprets the query, because if we go back 2 more, it does stemming on the word hat, which I can't see how that would actually change without it turning it into hit or something like that. But for other words, it could be finding a stem, an incorrect stem of the word, and thus doing an incorrect search. We are looking at translating instead from natural language into identifiers within the knowledge graph. So what is the identifier for the concept that you are looking for, and then search for that. And I have other examples where that works significantly better than searching using natural language. I don't know that it would get us to rescan the object unless the object was, if it came up a lot of times in searches and was wrong, was was correct according to the metadata, but not obviously correct in the image. Yeah, that, and it was common. That might prompt us, but yeah, it's hard to get things into the queue of digitization because we have so many objects that haven't been digitized at all. That rescanning things is a cost that reduces access to something else.
Thank you. Maria?
Thank you. Thanks, Robert. I have a question, and it kind of touches on all of the speakers, the presentations. You flagged that reinforced bias is a concern. You mentioned the word complacency in engineers and leadership. And Laura spoke about a responsibility gap. Those are really big flags for me. So I'm just wondering what the conversation is like in these teams and environments and industries, and why we're are we just continuing to move forward because it's there? Are we not really gonna look back in 20 or 30 years or 50 years and be like, man, we really shouldn't have gone there because we're currently undoing things that we probably shouldn't have done 100, what is that conversation like?
Yep, great question. So it is always an ongoing discussion, certainly at Yale. From our perspective, there is a trade-off between human labor and automated labor with regards to availability of the information. So, let me expand on that one. The ethics of information access to us can be divided into accuracy and recall, precision and recall, essentially, right? How much of our collection, particularly in the archives, is digitized? Not a lot. How much of the digitized stuff is described? Almost nothing. So is it better to have clearly labeled AI-generated text that describes the object based on the imaging work such that you can actually find it, or is it better to have a human do that work sometime in the next 2 decades? Because we have, our collection storage is measured in acres rather than in linear feet. So we are never, and we acquire more than we can possibly get through in terms of cataloging in every year. So our backlog is always growing, right? We will never, in our current mode, catalog everything. So then why are we collecting it? Well, it's above my pay grade. But why aren't we making it available in some way if we possibly can? Well, that is at my pay grade. So and that's why we're working on this, to be able to provide access to as many people as possible, or even just awareness that it exists, so that then they can come and see it for themselves if they want to, or they can interact with the image, or they can let us know that the AI got it wrong. I probably don't have time to show you, but on every page in LOCKSS, our knowledge graph cross-collection description system, there is a big blue button that says feedback, and it encourages people to click that button and tell us when things are wrong. We get feedback literally every day. I've had 4 or 5 feedbacks just this morning, so from different people. So yeah, we want to engage with users, and across the screen, the digital divide, that's tricky, but we have found that putting things online in a humble and not confrontational and not confident way, and inviting feedback is a way to find where things have gone wrong, that then lets us produce training sets or fine-tune models to be able to work around the errors that are reported. So we would rather have the information out there and it be wrong than to worry that nothing, everything, that it's not perfect, and wait until it is, because it will never be perfect. We've had, as a domain, many hundreds of years of making catalogs of collections, and they have never been perfect, regardless of it's a human or an AI that did the work. as one, if I have one more second on this one, one example, there was a person in our library catalogue who died in the year 39 trillion. That is after the heat death of the universe. So we found this person by doing a knowledge graph query of who is the oldest person in the collection. It's like 39 trillion years old, that guy's old. It was a miscataloguing where they transposed the death date and the barcode. So it is not that our data is perfect, far from it. But we want to be able to find when AIs make category errors, right? So then we can correct that category of error.